This video is for Lesson 6 of the Year 7 Light topic entitled Colour Part 2. At the end of the lesson you should recall that non-luminous objects are seen by reflected light. Understand that we see coloured objects because of the colours that are reflected off of them, and understand that coloured objects can appear to be different colours in different coloured light. Before we start today, a quick quiz on what we did last lesson. Can you pause the video, read the questions and just jot down your answers, and we'll go through them in a moment. So pause the video now. Okay, the answers to the questions then. 3 primary colours are of course red, green and blue. 2 primary colours mixed together make a secondary colour, and those 3 secondary colours are yellow, magenta and cyan. When we add the 3 primary colours together we get white. A filter absorbs some colours and transmits others. State what you would see and why you would see it if white light was shone through a blue filter. Well, the filter would absorb all the other colours but only allow blue to go through. And question 6, what would you see if you placed a red filter after the blue filter in question 5? Well, we've established that we only get blue light coming out of the blue filter. If we then put a red filter after that, the red filter will absorb the blue light, so you'll see no light at all. Okay, so now we're going to look at how we actually see coloured objects, and in the little animation that you can see here, we can see that we've got white light from a lamp, hitting a blue carpet. So the white light is represented by the 7 colours here, but the blue carpet will only reflect blue light. That's why it appears blue to us. The other 6 colours are absorbed. So if we turn the carpet to red, what colour light would a red carpet reflect? Well, it appears red because it only reflects red light. It absorbs all the others. What about a green carpet? Well, green carpet absorbs 6 of the colours and reflects only green. Now purple, which we're calling magenta, is of course made up of red and blue light, so it will reflect red and blue, which together make magenta. Okay, so we need a brief note on that in your books. If you put the title Seeing Colour, can you make a copy of the slide that we've got there? So pause the video and make your copy. Okay, so some more examples. If we've got magenta trousers, purple trousers if you like, and we shine a white light on that, then you should be able to see that red light is reflected off it, but also blue, because blue and red make magenta. If we have a white light shone onto a white object, well, the object appears white because all 7 colours are reflected, so we perceive it as being white. So just remember, we see coloured objects as coloured because of the light that they reflect off them. Okay, so that's pretty straightforward when we've got white light. What happens when we've got a different coloured light shining on different coloured objects? And this is quite a complex slide, so if you want to print this off, please do so. Otherwise, carefully copy this into your notes. Okay, so we're going to start off then looking at this sort of sports kit, red top and blue shorts in white light. Now remember, we see objects because of the light that they reflect. So the red top will reflect red light, so the red shirt looks red as you'd expect. And the blue shorts are going to reflect blue light. Okay, so that's what we'd normally see in everyday life using white light, light from the sun, light from our lamps in our homes. Now, if we take the same kit, but this time we shine only red light on that kit, then the red shirt will reflect red light. So the red shirt will look red. The blue shorts, however, will not reflect red light. They will absorb the red light, and therefore the shorts will look black. If we shine blue light onto our kit here, then this time the red shirt will not reflect blue light. It absorbs red and so will appear to be black. But blue shorts, as they appear in white light, will reflect blue light and so they will appear to be blue. Please make a copy of that into your notes and make sure you understand that. It's probably the most tricky thing that we've got to do in this little section of work here. So pause the video and make your notes. Okay, hopefully you've understood that. You don't have to copy this out, but I would like you to attempt the questions there here. So if I give you the top one as an example here, we've got a red object, red socks, and if that's been seen in red light, then the red socks will reflect the red light and they will appear to be red. If you shine blue socks on red socks, the blue will be absorbed and so the socks will appear to be black. Likewise, if you've got red socks and you're shining green light, the green light will be absorbed and the socks will appear to be black. Okay, have a go at the remaining ones now. Pause the video, see how many you get right. Okay then, so we've got a blue teddy and blue light is being shone on it. So the blue teddy will reflect blue light, so the teddy will appear to be blue. In green light, however, the blue teddy will absorb the green light, so no light will be reflected, so it'll appear to be black. Green camel in red light will appear to be black. In blue light it will appear to be black, but because green camels reflect green light, it will appear to be green in green light. Now the magenta book is a little bit trickier again. If you remember that magenta is made up of two colours, red and blue combined. So if we shine red light on a magenta book, it will reflect red light. If we shine blue light on the magenta book, it will reflect blue light. Now because magenta is just made up of red and blue, not green, then when we shine green light on it, no green light will be reflected and it will appear to be black. Okay, so you should now be able to recall that non-luminous objects reflect light in order to be seen. You should recall that coloured objects reflect some colours and absorb others, and that the colour that they appear to be depends upon the colour of light that they reflect. So a red book will reflect red light. The colour of an object depends upon the colour of the light that is falling upon it.